Welcome back to another lecture. Today we're going to talk about solutions to equations and what they mean and how to solve them. And we're going to use this building up what we know, building up from what we know about integers and what we've studied about them so far. So this is lecture 8, section 2.5. So here's something I've mentioned earlier. I even drew it out earlier. Whenever we're solving linear equations, we're either going to have zero solutions, and that's because linear, meaning line, whenever you translate this over into geometry, they're parallel, they never cross, zero solutions. We could have one solution, which is when they do cross, and where they cross is actually going to be the solution. So there's one solution, or they could be overlaid on top of each other, these lines, and we have infinitely many. Okay, so keeping this in mind, generally, by the way, especially in this course, you're just going to have one solution, right? If it's asking you to find the solution for it, it's probably going to be one solution. So let's start looking at that. What even is a solution? Well, we mentioned over here, geometrically, it's where they cross, but what it actually means, where they cross, the reason that's the case is it's on both lines. It's on this line, so that point is true to that line, and that point is also true on the other line. So we can use this kind of knowledge and this idea to try to build up solutions to equations. And we'll just jump right in with an example. Is 4, let's do negative 4, a solution to 3x minus 6 equals negative 18? And if you remember, whenever we talked several lectures ago about kind of solving equations, this is what this is doing. This is solving the equation, does negative 4 produce a true result? So let's plug it in and see if we end up with something true or if it's nonsensical. So 3 times negative 4 minus 6 is negative 18. 3 times negative 4, that's a positive times a negative, so we're going to get a negative. Minus 6 is negative 18. So we get negative 12 plus negative 6. I apologize about the noise in the background. Negative 18. Well, we go 12 units to the left, and then we do 6 units to the left. That's going to be 18 units total to the left. So does this make sense? Yes. So negative 4 is a solution. So now what happens if we try the exact same thing, but with a different one? Is negative 2 a solution to 3x minus 6 equals negative 18? Let's plug it in. 3 times negative 2 minus 6 is negative 18. 3 times minus 2, that's a positive times a negative. We're going to get a negative, so negative 6 minus 6, negative 18. That's negative 6 plus negative 6, negative 18. And then we go 6 units to the left, 6 more units to the left, we get negative 12. Does that make sense at all? No. So negative 2 is not a solution. Okay, so now we're going to use the properties of these integers to solve equations. And let me show you how we're going to do that. We're going to say some number, and we've actually done this implicitly before. Some number m plus 16 is 8. Well, if we take, if you remember from several lectures ago, if we add the same thing to both sides, it doesn't change anything about it. So if we add, in particular, the opposite of 16 to try to get rid of the 16, the opposite of 16 being negative 16, to both sides, everything should be fine. But now we have 16 plus negative 16. Those cancel out to 0. So we're left with m on the left side. On the right side, we're left with 8 plus negative 16. Go 8 units to the right. We can break that apart. Negative 16 is 8 units to the left, plus another 8 units to the left, right? These two make 0, and we're left with negative 8. I don't know why I wrote 18. Left with negative 8. So we just produced a solution for this equation using what we know about integers, which I think is really cool. So this is the case whenever we have addition. Let's look at whenever we have multiplication. Let's do negative 7x is 42. And again, this is multiplication. So we know that if we, again from a previous lecture, if we multiply both sides by the same thing, as long as we multiply the entire side by that, it remains the same. The equation is still true, or the equation is still false. It doesn't change the validity of the statement. So in this case, what we're trying to get down to is x is equal to something. So we can, this x has been combined with the negative 7. We've multiplied that negative 7 on, so we have to find a way to get rid of that negative 7, right, in order to get x by itself. So what we have, I'm going to write this just like this: negative 7 times x is 42. We haven't changed the statement at all. We're just writing it with parentheses now. We need to get rid of that negative 7, which is multiplied on to x. The way you undo multiplication is through division, right? And that's because anything times 1 is itself, right? And anything, let's say a divided by a is 1, and where a is not 0. Anything divided by itself, as long as it's not 0, is 1. So we can combine these two properties and say, okay, here's the 1 that goes there. So we can say a divided by a times x is x. And you say, well, this is just making things more complicated, and I understand, but we're going to use this kind of convoluted method of approach in order to solve this. So just remember, anything divided, if this coefficient of x is something divided by itself, it's 1, so it's just x. Okay, let's actually use that now to solve this, instead of just talking about the theory of it. So we want to divide negative 7 by itself, so we can get 1, so we can get x by itself, right? So how do we divide by negative 7? That is the same thing as, remember, division by negative 7, that's a 1. Division by negative 7 is exactly the same thing as multiplication by 1 over negative 7. So let's multiply both sides by not changing both sides. Let's multiply both sides by 1 divided by negative 7. So we have 1 divided by negative 7 times negative 7 times x is equal to 1 divided by negative 7 times 42. And we can kind of clean this up. We can combine these two terms and say negative 7 divided by negative 7 times x. And we can combine these two terms and do 42 divided by negative 7. Negative 7 divided by negative 7, remember, this is the case where we have a over a times x. This is just going to be 1x, which is just going to be x, right? 42 divided by negative 7, well, we have 42 divided by 7, which is 6. But we have a positive divided by a negative. If you recall from previously, a positive divided by a negative is a negative. So we have x is negative 6. And whenever we go and plug this back in, hopefully it makes sense. Negative 7 times negative 6. Well, this is a negative times negative. That's a positive, right? 42. And that is, in fact, the case. All right, I think this is a good place to end the lecture. Again, let me know if you have any questions or if we need to... I can always record like a bonus lecture or an additional lecture that if something's unclear. So thank you all.